So welcome everyone. So yesterday we had started magnetism. So in magnetism we studied the magnetic field due to straight wire. So we just had a very basic class and so on. But if you look at the PYQs, you will see that even the basics are enough to solve the problems of JEST. You don't need to master something as such. All you need is basics. And consistently, if you cover 30 basics in 30 single days, more or less you will qualify just with the good rank. So let's prove this. Okay, so let's do the PYQs and see how much information we can or how much we have done. Okay, so let's read the problem. So consider the three infinitely long straight coplanar wires. So there are three infinite long wires which are placed parallel to each other. Okay, so there are three wires and we have placed parallel to each other. The distance between the adjacent wires is d. So this is what I can imagine here. So this is wire number one, okay, wire number one, then we have wire number two, and then we have wire number three. Okay, and every wire is infinite wire, and the distance between the wires is d. So this is d, this is also d. Next line, each wire carries a current I in the same direction. So all the three wires carry the current I and the direction is same. Consider the points on either side of the middle wire. Consider the points on either side of the middle wire where magnetic field vanish. Vanish means magnetic field is zero. What is the distance of these points from the middle wire? Okay, so consider a point on either side of the middle wire. So either you can take it here or you can take it here. Okay, so let's just for a purpose, let's take it here. Right. So at this point, magnetic field is zero. And they are asking us, what is this distance? What is this distance from the middle wire? So basically, we need to find x. If you want, you can even find this x. Because if magnetic field is zero here, then magnetic field will also be zero here because of the symmetry. There is a symmetry, right? So you can take any of one of the point and find the distance. Perfectly fine. So we need to find x. Magnetic field is zero. It means magnetic field due to wire 1 plus magnetic field due to wire 2 plus magnetic field due to wire 3 is equals to 0. Okay, so all the three magnetic fields will combine together and give you total magnetic field 0, right? Okay, let's call it as 1, 2, 3. Now help me find the magnetic field due to wire 1. So I am writing the formula here. Magnetic field due to infinite wire is nu naught I by 2 pi distance, 2 pi r. R is a perpendicular distance. Okay, so because of wire 1, so what is the distance between wire 1 and point x? So what is this distance? Nu naught I by 2 pi. So this distance everyone can see is d plus x. So this is d plus x. Now you tell me, what is the direction of magnetic field? Inward or outward? Because of wire 1, the direction at this point is inward or outward? Right hand thumb rule.
Yes.
Thumb in the
Not
direction of vector. Rotate the fingers and see if your fingers are going in or coming out. Yesterday we had a big discussion. So everyone is saying inwards. So I also agree. So write here inwards. I'm just writing. Okay. So we are just writing it inwards. Okay. Now because of second wire, we can say nu naught I by 2 pi. Again, now the distance is only x because the distance of this point from the middle wire is only x. Again, you can again say that the magnetic field is again inwards. So here also inwards. Okay. And the last third wire, nu naught I by 2 pi, the distance, this distance is what? D minus x. Because this complete distance is d, and if you subtract x, you have d minus x. And now you can agree that now the magnetic field is outwards. right? Outwards, because if you keep the finger and then you rotate and then you have to come other way around and then it will be out. Because if you put your thumb in the direction of the third wire, you will enter here and you will come out here. So here you will end and here you will out. Your fingers will be in here and out here, right? Okay, so let's say I call outward as positive and inward as negative. You can choose any. You can put inward as positive and other way around. What I'm doing is I'm choosing outward as positive, inward as negative. So here I have put positive and here I have put negative. Total magnetic field is 0, right? So what I will do is now I will just solve this out and I will find x. So how many of you can solve this x, right? Perfect. The question is done. You can do from here. I don't have to do much, right? So from here everyone can do the maths, right? What do you say? Perfect. Yeah. So let's not waste the time. You do the maths, right? So this is basically, so what in this was very advanced topic. So this was a very simple basics, all you need. So this is your JEST PYQ. This is not the question which I am creating by myself. Yesterday all I do was I taught you JEE mains. What I teach to JEE main student, I just taught you that, and JEST is repeating the question. Okay, so same question JEST has asked. Now, the next problem is little difficult, but we covered it. We covered this problem as well, but this is little bit, you can make mistake in this. Okay, so let's see what is this question. So there are two semi-infinite wires. Semi-infinite means one side of the wire is infinite and only one side of the wire is infinite. They are placed on the x-axis, one from minus infinity to minus d and the other from positive d to infinity. Okay, so first of all, let me show you the x-axis. So this is your x-axis. Okay, so let me show you the plane as well. So this is one plane. This is x-axis. If this is x-axis, this plane is which plane? XY plane, XZ plane, or YZ plane?
YZ.
Which plane is this? If this is x-axis,
YZ.
this is very basic thing. What do you think? YZ, right? So YZ plane. So this plane is known as YZ. Why? Because this axis is Z axis and this axis is Y axis and this is your X as I have shown you. Okay. So this
Backward will be Y.
YZ plane. Perfectly fine. Okay. Now what is happening here? So two infinite wire, one wire is from minus infinity to minus D. Okay. So we have to come from minus infinity. So basically we are coming from minus infinity and we have to come till minus D. So this point is minus D. Basically this distance is D, right? Minus D. And the second wire you can see is from D to infinity. So positive D to infinity. So the second wire is from positive D to infinity. Okay. Positive D to infinity. So this is my wire number 1. This is my wire number 2. Okay. So this distance is also D and this distance is also D. Okay. And this is 0. This is 0. Okay. The middle part is 0. Right. Okay. Perfect. Now, what is the magnitude of the magnetic field? So they are asking what is a magnetic field. Now, this line is also important. Both wires carry the current I in the same direction. So both of them are carrying current in the same direction. So this is also I. This is also I. Now, the last line of this question, what is the magnitude of the magnetic field at a distance d away from the center of this gap? So distance kahan se measure karna hai? From where you have to measure the distance? From the center of the gap. So center of the gap is O. Center of the gap is O. So I have to measure this distance from O. How much distance? D. And this distance is in YZ plane. You have to move in YZ plane. So it means I have to move in YZ plane, means here. This distance is D. I have to find magnetic field at this point P. Why I moved up? Why I did not came here, or why did not I came here? Because I have to go in YZ plane. This is my YZ plane. And I have to measure the distance from the center of the gap. So this gap which you have from its center, वहां से in the YZ plane distance d. So basically I have to find magnetic field at point P. Okay, so this distance is d and this distance is also d. Perfectly fine. So let's call this point as O, this as P, and let's call this point as A, and we can call this point as B. Perfectly fine. We are ready with this. Now you use your brain and tell me which formula we will use. Okay, and I will give you option here. I will show you two formulas which we covered yesterday, and which one should we use? Left hand one or right hand one?
Which contains
Left
angle
hand one
sine
or right hand?
alpha into perpendicular.
Think about it. Right hand, because you see right hand one formula is ki when your point is outside the wire. So this is your wire and your point is outside, right? So that I want to take. And also one more thing that I want you to remember, ki from this formula I will only find the magnitude, and for the directions I will use right hand thumb rule. So I will not worry about positive negative. I will only worry about the magnitude. One person is saying right left hand. No, why we will use this formula? Because for this formula, point is inside the wire. For this formula, point is outside the wire. Okay, so your wire is only till this point and point is outside. So look at this formula very carefully. We will use this formula. Okay, so let's come at the bottom of our question. So let's come here. So the formula that I have to use, you can clearly see this is my wire. So my wire is only till here, but your point is outside the wire. That is why I'm using the second formula. So I get nu naught I by 4 pi d sine beta minus sine alpha. Okay, I will not worry about is it alpha minus beta or beta minus alpha. I just need magnitude. I just need a number. Okay, so I just need a number. If I need a number, I can even put a modulus. It means I don't put a modulus, but in your mind think about I only need a number. Okay, so I need two angles. So what are the two angles I need? So one angle is this, and second angle is this. Second angle everyone can predict. What will be the second angle? What will be the second angle?
90 degree.
90 degree. Because whenever one side goes to infinity, if the side goes to infinity, we learned that yesterday. If the side goes to infinity, the angle becomes 90 degree. So one of the angle is 90. Okay, so let's say this angle is let's say this angle is 90. Okay, so let's say alpha is 90, and now let's find beta. So this is a beta. What I'm going to do is I'm going to find sine of beta, right? So you know whenever your perpendicular and base are same, angle is 45 degree. Very simple. This everyone knows. If your height and base are same, then your angle is 45 degree. So sine 45 degree. So this angle beta is your 45. So if beta is 45, this is 1 by root 2. So nu naught I by 4 pi d into root 2. Okay. And then similarly, because of this wire also, the magnitude of the magnetic field will be. So this is B1, and B2 will also be nu naught I by 4 pi d root 2. Now you have to make the last final decision. Is the direction same because of both wires or opposite because of both wires? That is the only decision you have to make. So now you tell me, because of this wire and because of this wire, magnetic field will be in the same direction or opposite direction? Are you changing your thumb? No.
Same
So
direction.
this is a thumb coming out. This is a thumb coming out. So same direction, right? So if it is in the same direction, all you have to do is add them. So you just add them. So it will be nu naught I by 4 pi d into root 2. Okay. So that's all. Oh, sine 90 is 1. Sorry. Sine 90 is 1. So that is my mistake. So I need to use 1 here. Okay. So, sorry. I made a mistake. So sine 45 is root 2 and this is 1. Similarly, here also 1 by root 2 minus 1. It's a very silly mistake. Sine 90 is 1. Yeah, sorry. Okay. So that is what we have to do. So what we have to do is 2 times 1 by root 2 minus 1. Okay. So you can see nu naught I by 2 pi d into 1 minus root 2. Okay, so because this 2 and this 2 will cancel, do not worry about the negative positive side, right? Because what we need is a magnitude. Okay, okay. So that is the beauty here. So don't worry about is it 1 minus root 2 or root 2 minus 1, because you only need to worry about the magnitude. Because if you do the reverse, only positive negative signs will change, the magnitude will remain same. And in the question they are asking you the magnitude. What is a magnitude? So that is why your option number B is correct. So I hope for everyone is clear with this, right? Everyone understood, right? From the very basic formula, how we can solve the problem. I did not explain anything new here, right? So what we did is just the same thing. Yes, any doubt, anyone have any doubt, please go ahead. I will stop here for 10 seconds. Anyone, please. This is the third question. Now, how many of you quickly recognize the question? इसको करवाने की जरूरत, do I need to do it? Yesterday we did it, right? The same question we did it yesterday. Hexagon. And you see, yesterday I did not knew that it was a JEST PYQ. Yesterday I gave you, we did JE question. So that question I picked from the JE. But you see, just the same question they have picked up. So yesterday, if you remember, क्या हुआ, भूल गए क्या? याद है नहीं? Everyone remember yesterday's question? Is it same? The strength of the magnetic field at the center of the regular hexagon. So yesterday we have done it, right? So what we did, if you remember, for one wire we found out and then we multiplied by 6. That's all. So this is what we did, right? Okay, perfectly fine. So these were the 3 questions which were asked in JEST from the topic which we covered yesterday. Okay, so you see all the 3 questions does not need any hi-fi physics. They need a very basics. If your basics are clear, the questions become simple. Okay, so that is the whole idea. I only taught you JEE level and then we can do the questions. Okay, similarly today we are going to cover one more thing, which is basically magnetic field due to circular wire, right? So and also we will do some basic questions of it. So what is a magnetic field due to circular wire? Okay, so this is my circular wire. The radius of the wire is a, and I want to find magnetic field at this distance p. So basically I want to find magnetic field on the axis. Circle की axis पे I want to find the magnetic field. I don't want to find magnetic field at the center. Center पे नहीं. I want to find it on the axis. And this point is at how much distance? X distance. At distance x. Okay. So what is a magnetic field's formula? Again, this formula is coming from which law? Just a recap I am asking you. So this formula is coming from which law? Which law I have to use? So it comes from Biot-Savart's law, right? Yesterday we talked about it. So it comes from Biot-Savart's law, and that's all. So the formula says nu naught I a square by 2 x square plus a square की power 3 by 2 into k. Okay. So this is a simple formula, and few important things about this you have to keep in mind. Number 1, magnetic field is axial. Means it is pointing along the axis. Means the magnetic field is pointing along the axis. The direction of the magnetic field will be in the direction of the axis. So whatever is the direction of the axis, the direction of magnetic field is also in the same direction. Okay. Okay. Now, this is very good. And if you draw the graph of magnetic field versus x, then the graph will be something like this. So you can see at the center, magnetic field is maximum. And as you move away, the magnetic field decreases. And if you're at very, very far distance away, the magnetic field is almost like 1 by x cube. It is almost like 1 by x cube. Why? Because if x is very large, so let me write everything as such. And if x is very, very large, then I can ignore a square. This thing can be ignored. 3 by 2. This 2 and this 2 will cancel. It means it is inversely proportional to x cube. Okay. So if you are very, very large distance away, so then your magnetic field is almost like 1 by x cube. So this kind of questions can be asked to you in 1 marks in any of the exam. Okay. Even someone can ask you like that. Okay. What is the significance of this? Anyone? I challenge you. I can challenge anyone. Let's see. Yesterday in the poll, someone said that we already know the basics. So let's see how many basics you need. No. What is the significance ki magnetic field varies as 1 by x cube? Anyone? Yes. Kritna is right. But you cannot see Kritna's message. So I can see her message. What about others? No, it's not quadrupole. It's a dipole. It's a dipole. So in multipole expansion, you will learn whenever magnetic field is inversely proportional to x cube, it means you are talking about dipole. So one side of the ring is always north and other side of the ring is always south. It means you have two poles. One side is north and another side is south. Okay. So that is one of the significance. So if you will find the magnetic moment of this wire, it will be non-zero. So if you find magnetic moment of this wire, it will be non-zero. Okay. So that is the significance. Okay. So there are few other things. So if you have n turns, let's say this is a single turn, right? So it's only one wire. But let's say I take n number of wires at the same place like this, n number of. If I do something like this, then it is a solenoid. I'm not talking about solenoid. At the same place, I am wrapping the wires multiple times like this. Then what you do is you multiply this formula with n. So all you do is multiply this formula with n if you have n number of turns. Okay. Sometimes we also need what is the magnetic field at the center. Sometimes they don't ask magnetic field on the axis, they ask magnetic field on the center. So if you're talking about center, then you can put x0, because if you are at a center, x will be 0. So if you put x0, your magnetic field will become nu naught I by 2a. Nu naught I by 2a. Simple. So this formula also you should remember, very important. And sometimes they don't ask for entire wire. They ask for an arc. So let's say I don't have an entire circle. All I have is an arc. Okay. And I'm asking you the magnetic field at the center. At the center. If I have a complete circle, then the magnetic field will be nu naught I by 2a. But if I don't have a full circle, then I have, let's say, arc, and arc having an angle theta. Some theta will be given like 60 degree, 30 degree, some angle will be given. So then you multiply by theta by 2 pi. Theta by 2 pi. Basically, what is the total angle? Total angle is 2 pi, and how much angle is given to you? Theta. So that is why you are multiplying by theta by 2 pi. Unitary method, simple class 10th unitary method. Right. And if you have a complete circle, then you don't worry about this, because you see 2 pi by 2 pi is 1. Because if you have a full circle, it means total angle given to you is 2 pi, and the total angle is also 2 pi. So 2 pi by 2 pi is 1. So then this thing is ignored. But if you don't have a full circle and you only have is an arc, then you multiply by theta by 2 pi. Perfectly fine. Okay. So that is some of the important things you should keep in mind. Okay. Yeah. So now we will do the questions. And any doubt till this point? Yeah. Anything? Perfect. All clear, I think. Okay. So today I'm teaching little fast, but any doubt you have, please go ahead. Okay. Yeah. Okay. Sure. Done. Let's go for this question. Now, how to find direction of magnetic field? No. No. B is along the axis of the circle, not along the current axis. So yeah, direction only. You are asking for the direction. So let's see how to find the direction. Okay. That is what I was going for. Direction. So how do you find the direction of magnetic field? So again, you use a right hand thumb rule, but now you use right hand thumb rule in little different way. So now initially what you were doing, you were taking your thumb in the direction of current. So when you have a straight wire, what you do is you take your thumb in the direction of wire. But now you see you have a circular wire. So now you cannot take your thumb in the direction of circle, right? So that is not possible now. So what you do is now you take your fingers in the direction of vector. So use the right hand. In whatever direction your vector is rotating, rotate your fingers also. So your, in this case, you can clearly see your, it is clockwise rotation. You can, sorry, anti-clockwise rotation. So rotate your fingers also in anti-clockwise direction. So thumb is going up. So it means the direction of magnetic field is up. Okay. In this case, you can see the rotation is anti-clockwise. So now rotate your fingers in anti-clockwise direction. So thumb is going down. So the magnetic field is downwards. So in this very simple way to find magnetic field, rotate your fingers in the direction of current and use your thumb for magnetic field. Okay. So that is how you find the direction. But one thing that you see is magnetic field is on axis. Either it is up or down, but it is along the axis. Either it is upward in the axis or downward in the axis, but it is along the axis. Okay. So that is a point of thinking here. Good. Okay. So now we are ready for the basic questions. So we will do it. So what is the first question? The magnetic field at the center of the wire loop. So basically we have to find the magnetic field at the center. The value of R1 and value of R2 is given, current is given, and a figure is given. Okay. So we have four things here. Four things. Number one, number two, number three, and number four. What is the magnetic field due to number three and number four? What is the magnetic field due to number three and number four?
Zero.
Zero. Why zero? Because yesterday I told you, if you have a wire and the point is on this axis, then magnetic field at these points will be zero. That is why magnetic field due to number three and number four is zero, because this point is on the line. Okay. So all I need to do is find magnetic field due to number four and number one. Okay. Okay. This is not circle. This is semicircle. So how do I find magnetic field? Nu naught I by 2a theta into 2 pi. Okay. So in a semicircle, how much angle do I have? I have angle pi. 180 degrees pi. So I put my theta as pi. So I get pi by 2 pi, which is half. So basically nu naught I by 4r. Okay. So here I use 4. Here also I use 4. Okay. So I have written by mistake 2, but it is 4. Okay. Because it's a semicircle. So for semicircle, it will be nu naught I by 4r. For radius. So for a bigger circle, the radius is r2, and for the smaller semicircle, the radius is r1. Now all you need is directions. So let's find directions also. So for this wire, this semicircle, let's use the right hand. You are moving anti-clockwise, so let's move anti-clockwise. The thumb is coming up, or you can even say out, whatever you want to say, out, or you want to say up, whatever you want. And also for this, you can see it is also going anti-clockwise, right? So for this also, because of this also, the magnetic field is coming up. So for both of them, magnetic field is coming up. Now you can do this problem. You can put the value of R2, you can put the value of R1, you can put the value of current. So all you have to do is add both of them, because the direction of magnetic field because of both of them is same. Okay. So whatever answer you will get is correct, because all you have to do is put the values. Okay. Everyone clear with this? Don't worry about the answer. All you have to do is put the values. Clear everyone? Yeah. सबको समझ आया ये? Straight wire cancel नहीं हुआ था. It was not cancelled. They both were not cancelled. Yesterday I taught one concept ki let's say you have one straight wire and if the point is on the line of the wire, मतलब ये वायर है, दिस इज अ पॉइंट, सो मैग्नेटिक फील्ड यहाँ पे हमेशा जीरो होगा. तो बिकॉज ऑफ दिस वायर मैग्नेटिक फील्ड हियर इज जीरो एंड ऑल्सो बिकॉज ऑफ दिस वायर ऑल्सो मैग्नेटिक फील्ड हियर इज जीरो. तो कैंसिल नहीं हुआ है, दोनों की वजह से जीरो जीरो है. राइट, ओके, परफेक्ट. ओके, last question for today and the last thing for today, a very simple thing. Now we have to find magnetic field because of these four cases. So we have four cases. Okay, and I will just guide you and then you do it yourself, but I will guide you in a very good way. So what you have in first case, you have three things: one full wire, straight wire, then full circle, and then full wire. Okay, now what do you call this wire? What is this wire? Infinite or semi infinite? This wire is infinite or semi infinite? Semi, because you see this is your wire and this is your point, so this is semi infinite. This wire is also semi infinite and this is full circle. Magnetic field due to semi infinite wire is nu naught I by 4 pi r. Magnetic field due to full circle is nu naught I by 2r, and magnetic field due to again semi infinite wire is nu naught I by 4 pi r. So semi infinite, full circle, right? Yeah, you can also do that. So Smile also had a good point. You can even consider this as a full wire and then just consider one wire as infinite. That is also okay. Yeah, that is because anyway, if you add this and this, two semi infinite combined together to give you one finite. Yeah, that is also okay. Okay. Now, more important thing is directions. Okay, directions. So because of this wire, the magnetic field will be coming outwards. Because of this, magnetic field will be going inwards, and because of this, magnetic field will be coming outwards. Now you have to be good in the directions to understand this. So let's see. So first case, this wire, right? So what do you do for this wire? So take your thumb in the direction of wire. Now rotate the fingers. When you rotate the fingers, you go in from here and you come out from here, because this is the direction of the vector. If you put your thumb in this direction, you will go in from here and you will come out from here. So because of the semi-infinite wire, the magnetic field is outwards. Outward is positive, so let's put positive here, let's put positive here. But because of this circle, now circle is clockwise, so now take your fingers and rotate. If you rotate your fingers in the direction of circle, the thumb is going in. That is why I said magnetic field due to circle is in, and because of in we say negative. So your magnetic field will be nu naught I by 4 pi r minus nu naught I by 2 pi by 2r plus nu naught I by 4 pi r. Yes, यहाँ पे किसी को anyone have a doubt? Clear हुआ? Magnitude as well as the directions. You have to match the following basically. So this is a match the following question. Is it clear or should I do again? Please go ahead. If you have doubt, I will go again. This is very important. Once you understand this concept, no problem will go wrong. Everyone, is it clear? If you are clear, I will move. Otherwise, if you have doubt, just write doubt. I will explain again. Don't worry, there will be no pressure on you. Okay. If you ask a doubt, I will not ask you what is a doubt. I will just explain again. Okay. If you are, yes, someone said doubt, so let's go again. Okay. So what we can do again? Yeah, please, let's go again. Let's be simple here. Okay. So let's remove this and let's go again. So how I have made my diagram? So this is my semi-infinite wire. Then I have a full circle, and then I again have one more semi-infinite wire. ठीक है जी? Okay. 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 because of semi-infinite wire, the magnetic field का magnitude is nu naught I by 4 pi r. Because of semi-infinite wire, the magnetic field का magnitude is nu naught I by 4 pi r. Okay, I'm just asking, writing the magnitude, and this is a full circle. So because of the full circle, the magnitude is nu naught I by 2r. Okay, so I have written the magnitude because of all three. Now I need directions. So for directions, what I need to do, so if it is a straight wire, I use my thumb. So I use my right hand thumb. So your thumb should point in the direction of vector. So if your vector is going here, so your thumb should also go like this. Now I'm daring you to rotate the fingers. If you rotate the fingers, you will see that your fingers will enter here and it will come out here. So your finger will enter here and then from the other side it will come out. So magnetic field at O will be outwards. So it means magnetic field due to wire is outwards. Now because of the full circle, now for full circle what we do? For full circle what we do? Right? Rotate your fingers. So if you rotate your fingers in a circle, you see I am rotating my fingers in a circle. My thumb is going in. So in. Okay. So whenever I have outward field, I put positive, and whenever I have inward field, I put negative. Simple, done. That's all. Okay. So that is done. Yes. Yes, Ashwini, you are right. Ashwin, you are right. Anti-clockwise means coming out. Clockwise means going in. See, Pranjal, what you are saying, you can send such questions. So you can say if toroid is placed nearby or like that, we have to add them. So if you have something else as well, we have to just add because of that also. So if you have toroid also, then we will add it because of the toroid. Okay. So if it is infinite, it has to be divided by 2 instead of 4. No, don't remember things like this. If it is finite or infinite divided like this, study straight wire differently and study circle differently, and remember formulas for both differently. Don't confuse it with like that. Okay. Okay. Now second problem. Now you have again three things. You see here. This is semi-infinite wire. This is also semi-infinite wire, and this is semicircle. This is semicircle. Okay. So semi-infinite wire. So I am removing this now. Oh, by the way, I have done it here also. But yeah, for semi-infinite wire, the magnitude is nu naught I by 4 pi r. Yesterday we did this. For semicircle, the magnetic field is nu naught I by 4r. We just did in the previous question. And again, because of the semi-infinite wire, the magnetic field is nu naught I by 4 pi r. Now, again, the main problem is in directions. So let's focus on directions. Because of this. So take your thumb in the direction of vector. Right hand ka thumb in the direction of vector. If you rotate the fingers, you will see your fingers will go in from here and out from here. In and then out. So it means at point O, magnetic field will be out. Okay. Then semicircle. So now semicircle you can see is in anti-clockwise direction. So take your fingers, rotate. Anti-clockwise, your thumb is coming out. So again out. And in the last case, you can see this is your semi-infinite. So now keep your thumb in the direction of the wire. If you rotate your fingers, you can see your fingers will go in here and out here. It means at this point, again, it will be out. So all three are out, so you add them. All three are out, so you add them. Okay. How to identify semi-infinite wire? You see, one side is infinite, and the point is on the edge of the wire. Right. So let's say if it is an infinite wire, point will be somewhere in between. Right. But if it's a semi-infinite wire, one end will be long, but the point will be on the second edge here. Right. So this is a situation here. You can see this is semi-infinite wire, and point is on the edge of the wire. And I'm calling this as a semicircle. This I'm taking as a different thing. This is semicircle. Okay. Okay. Now third case. What will be the magnetic field due to this thing? Very simple. Because of this part, what will be magnetic field?
Zero.
This part. Zero. Again, the same concept, you see. Right. So this. So if you have a wire and the point is on the line of the wire, so you have a wire and the point is on the line of the wire, then magnetic field is zero. So इसकी वजह से magnetic field is zero. This is semicircle. Semicircle की वजह से magnetic field is nu naught I by 4r. And this is semi-infinite. So semi-infinite की वजह से nu naught I by 4 pi r. Now directions. Now you do the directions yourself. I have written the directions here, so you can try the directions according to. You can practice the directions. Okay. And in the last case, again, you see magnetic field because of this, and this will be zero because you see the point is on the line of the wire. The point is on the line of the wire, and all you have to do is find the magnetic field due to semicircle. So that will be just simply nu naught I by 4r. Okay. Now Agyatan asked that how did we find the magnetic field due to semicircle? Okay. So we use this formula, arc formula. Nu naught I by 2r, 2 into radius, theta into 2 pi, and you know for a semicircle theta is pi, half of the 180 degree. So if you put theta as pi, so pi and 2 pi half will come, so that is why you get nu naught I by 4r. Okay, good. So this is the 4 cases I got. Anyone have any doubt in one of the 4 cases? You will always see the question like this. So even if you do the PYQs of CSIR NET Part B, you will find many of the same questions. Okay, even though this question is from JEE, but you will find this same question in NET and as well as in GATE. So just like yesterday, I'm also going to give you homework. So this is your homework. Question 1, question 2, question 3. Yeah, so 3 questions are your homework. Okay. So you try these questions out, discuss with each other. Yesterday, I see no discussion in the groups going on, but try to discuss with each other, get the answers. Okay. These notes are already shared in the group, so you can see there. Yes. So today, all I have is covered. So any doubt, anyone, please go ahead. Right. You can ask anything. Yeah.